maintenance, top and bottom. I can put these, Peltiers are cheap, by the way, but I'll show you what's not cheap. But the Peltier device itself is like not that expensive. If I go to my Amazon account, let me look it up real quick. If I go to my Amazon account, I gotta go to my lookup list. 5 of the big Peltiers that I want to use are $27. So they're we'll call them $5 a piece. Okay? So these big ones on the side here that are going to do the 12715 models that do 15 amps instead of 3 amps like he used, these things cost $550 per, okay? So what I plan on doing is, this is the big cooling block that I have selected. This right here that I selected right here, this is called a maintenance Peltier, which maintenance Peltier, like remember he had some on all the times that are going to maintain the temperature. He has some for cooling and he had one for cooling and one for maintaining, right? I don't know what mine are going to be, but I'm saying I'm going to have some maintenance ones. That's going to be on the top here. And the ones on the side here, I actually did them to dimension. Right there, that is a, which one is it? It's this one. Maybe, okay, I might need to adjust my shapes a little bit. That right there is the 12715 Peltier, okay? It's going to have wires coming out here. The hot side points in towards the cooling block, and the cold side points outwards, okay? Now, when I say it points to the right here, what I'm also going to do, and I went and priced this out, okay? These are what I call heat pipes, okay? These are called heat pipes, or I'm calling them heat pipes. They're copper, and originally I was doing cylindrical rods, but I kind of thought more about it, and I've found a better source where they're even cheaper. I totaled up how much I need, so I measured all of these, and there's 16 of them per side, per Peltier. And I said 1, 2, 3, 4. And if you do 4 of them, I need 26 feet of heat pipe. And it's not $140. It's, yeah, see, I got to fix that too, because I've updated that. I need 5 sections of 6 foot. And I found a website where I could get 5 sections of 6 foot at $8.34 each. So it's like $41. That's like equal 41.x USD, right? So, and there's the website for it. It's really a good, looks like a good price to me. And then what I did is that when I set up these curves, I measured them out equally across the surface. And what the plan is here is you're going to have a Peltier device. You're going to have a Peltier, come on. You're going to have a Peltier device. Then on top of the Peltier device, you're going to have a copper plate, okay? There's going to be a copper plate. And then soldered to the copper plate, I'm going to have these heat pipes, okay? 16 heat pipes per copper plate. So, and from the side view, if you look at it, you think about your copper plate, and you get the heat pipe bent. And what I'm going to do is I'm going to set up dowels, and I measured how big the dowel had to be, and I got how many inches are needed for 16 pieces for each one, blah, blah, blah. So I'll have a dowel. I'll take the heat pipes. I'll bend them. I'll restrain it on the end here on the dowel, and then I'm going to bend it one quarter of the distance. I'll bend it on the dowel, so I know exactly how big these dowels have to be. I'll bend the heat pipes and then have the straight portion come to another piece of copper plate, okay? Now, at the end of this copper plate, I got a couple designs I can do. One is I found these little aluminum fins that are 40 millimeters by 40 millimeters. And what I could do is I could put drill holes through here and put tap, and I can put a screw through here to where I could put 4 screws, or 1 screw on each corner. I'll probably do 4 screws for sure. But I'll have a copper plate, because copper, just so we're clear, copper has a conductivity 50% better than aluminum, but aluminum actually dissipates heat better than copper does. So when you're trying to conduct heat, you want to use copper. When you're trying to dissipate heat, you want to use aluminum, okay? That's one of the things that I think everybody on YouTube is missing. And maybe it's copper's pretty expensive. And maybe they don't want to deal with it, or maybe dissimilar metals. I'm not exactly sure. I'm gonna have to figure out why, right? Um, so, and it probably is because of dissimilar metals. I'll have to figure that out. That's probably I'm probably gonna blow my system up, but we'll figure that out. I'll figure out what I need to do to have aluminum and copper together. Okay. So, or maybe I can't. Maybe it has to be. No, I'll make it. I'll make it work. Yeah, I'll make it work. So okay, I need to do research on that. See all the things that need to be done. Research, copper touching aluminium. Yeah, I don't even want to try to spell aluminum. So that's the plan right now. Is to have the plan is to have the Peltier device, have a copper plate on top of it using heat conducting grease, soldering heat pipes from the copper plate, bending them using dowels, soldering them to another heat conducting copper plate, and then dissipating using an aluminum fin plate. Okay, so that's my plan right now for the beer Borghini cooling system. Okay, now inside of the coolers, come on, really? Inside of the coolers, I said to myself, well, I'm gonna have to protect these, and I don't show the fans here because I didn't work on this one. I started working and then I moved to the bigger one, but I'll show you why. So inside of the cooler, I said I'm going to have to protect that somehow. So I'll have a piece of steel or a piece of stainless or a piece of aluminum or a piece of something, okay, with like spacers. These are going to be spacers with a hollow tube that I can screw through. I'll have spacers in here so that if you hit this plate, it protects. If you hit the plate, it protects these. It protects the coolers, right? So this is like a protection plate, and it only needs to be big enough to protect these plates, right? It doesn't need to be any bigger. So I'm going to have screws go through these spacers. I'll have a screw go through. This purple represents plywood. So these are, I think it's 11/32 plywood that I went to Lowe's, big box store. Just check the different size plywoods. You could get smaller plywood. You could get bigger plywood. For design, I said, let me use 11/32, right? It's going to form a box on the inside, okay? The floor is going to be plywood as well. I don't show the floor in here, but I want you to just understand that the floor is plywood. The four sides are plywood. The keg is going to be put in from the top, okay? So you will lift the keg up, you'll put it inside, and that's another reason I have to protect this stuff, right? Because you're going to, as you're putting it in, you might bump stuff or whatever, right? But once you get it in there, you're good to go. So the floor is plywood. And then underneath the plywood is insulation, yada, 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 right? So we got the keg, we got the cooling system in here. Now there's going to be, like I said, there's going to be fans or something to move air over these cooling elements. We got the water cooling to remove the heat. And doing this, I saw one guy use kind of a water cooling system, but his wasn't as good as mine is. And I think he got temperatures inside of -7 C inside here. So I'm going to really be able to cool this bad boy down, okay? Now, how did I calculate that? Let me think. Oh, I did some calculations. I lost them though. Maybe I did. Did I lose them? I'm just looking. Give me a quick second. When I designed my Peltier system originally, I designed it for a 4-hour cooldown of a keg. And I calculated how much heat I needed for 4 hours to take 5 gallons and cool it down in 4 hours. That's what I originally calculated it's based on. And I came up with that I would use these bigger ones, right? Yeah. So I still, the Peltier, which Peltier devices I use is still a little bit up in the air, just so we're clear on that. I haven't done, my design is not final, but it's getting close, right? So the Beer Borghini Junior, outside of the plywood, okay, so I was thinking about the cooling. Anyway, so I have plywood, and then, and I, like I said, on the floor of the container, I have plywood, and then I have 2 inches of insulation all around. This is polyurethane insulation, 2 inches around the entire box. And again, on the bottom, I'm going to have 2 inches of insulation as well, okay? Then on the outside of that insulation, I'm going to have another layer of plywood going around. It's the brown color. So around the 2 inches of insulation, I'm going to seal all of that with another kind of ring of plywood, okay? And then that plywood is going to be framed with 2x4s. This is a vertical 2x4 here. This is a horizontal 2x4. So on this goes from the top to the bottom of the unit. And then on the top of the unit, I'm going to have a 2x4 going like the one I have selected. It's going to connect the tops. And then on the bottoms, I'm going to have another 2x4 connecting the bottoms. So I'm going to make a cube, if you want to think of it that way, a cube of 2x4s. And I'll click on them real quick. I'm going to make a cube of 2x4s that enclose the unit, right? That gives it structural integrity. And then, and the plywood, you see the plywood sitting inside there, so the plywood would actually be screwed into the 2x4s as well, right? So once I had that in place, then I was like, oh, well, there's spaces between these 2x4s. Let me put 1 inch of polyurethane insulation, because this is blocked with wood vertically all the way from top to bottom. So what I'm going to do is in these spaces between the 2x4s, remember at the top I have a 2x4 and at the bottom I have a 2x4, but between the top and bottom 2x4, I'm going to put this piece of 1 inch insulation in there and put some liquid nails or something so it's glued to the plywood, but it's going to provide another insulating layer. Now, I've looked at putting 2 inches in there, but if you put 2 inches in there, it hangs over the unit. Let me go like this. I'll show you what I mean. It hangs over the unit by some amount, and then that would get ripped and torn and stuff like that. So I decided let's keep it inside, because ultimately I've been thinking about sewing a canvas bag that will go around this whole thing. So it'll be in like I can take canvas bags and I can dye them in my washing machine. I can do like a tie-dye canvas bag. So I'm thinking about going to the store, craft hobby store, buying canvas, or maybe I'll go online, buying canvas and literally sewing a canvas bag that fits around this thing, and then painting stencils on it or tie-dyeing it or doing some cool designs. You know, it's a beer Borghini, so maybe I do something car-related kind of ish, sort of, right? So I thought that'd be really cool, right, with a canvas bag around the outside. And that canvas also will provide another layer of insulation. Although it's not the best, it'll provide some insulation, right? So this was my original beer Borghini design. And you can see here I put little dimension indicators. So my keg, I said I want 1 inch of space all around. On 3 sides, this cooler is going to not have 1 inch, but oh well, right? But it could be dropped in there pretty easily. You know what I mean? Now, do you put the keg in here, then fill the keg, and then pressurize it? Or now, I haven't talked about the lid here, but this thing's going to have a lid. Now the lid's going to, obviously the lid's going to cover the whole top, but it's only going to be go down in this area here, right? So I haven't designed those details yet as far as how the lid gets designed exactly, or that's work I have yet to do. I have to do like a side. You see my side views are pretty rough right now, right? So, but I'm gonna do a side view design of this before I start purchasing and building, right? I got to convert this to side, so I know exactly how everything works, right? Okay. So this was my original concept, right? And as I was doing this, I started coming up with some ideas, right? As I was designing it, I was like, oh, wouldn't it be cool? What if I had a tap on top of this thing? So rather than just hold beer here, obviously you have to access your beer somehow. Well, what if on the lid you put hinges and you know what I mean? What if you have your beer taps on top? You put a beer tap on top of this, and then it was like, well, that would be cool. Oh, I forgot to mention, this is going to have wheels on it too. So it's going to have wheels and a handle, kind of like a dolly. So you can transport it around places, right? So it'll have wheels and a handle. So I'll be able to pick this, just grab the handle, take it to my neighbors, right? And maybe go have beer with my neighbor from here, right? One of the ideas it's just an idea I had, right? So I was like, well, I have to have a tap on top. Well, if I have a tap on top, then I also have to have CO2. Where's CO2? Somewhere on here. Option to have a place to mount / hold small CO2 bottle. So I did some research, and you can actually get, they're made for these kegs. You can buy these little CO2, the little CO2 bottles you use like in your airsoft guns and stuff like that. You can charge this thing with those, okay? So, and they hook right up to the kegs. So it's pretty freaking awesome. You can have your CO2, you can have a tap on top of here, and you can cart it to the beach and have a keg at the beach. The other thing I guess I need to mention is that this can run off a 12-volt supply, okay? So you could have this plugged into your car at the beach, having a party, having a fresh keg at the beach. But as I was designing it, I came up with ideas. I said, well, I have to have a tap on the top. And then I said, well, what if I had charging stations on top, USB ports, with a weatherproof enclosure, and you could charge your cell phone, have cables with cell phone connect. You could charge your cell phone. That'd be kind of cool, right? Now, you could have this plugged into your car. So your car could be charging this, running, keeping this cool, and you could be charging, your cell phones, etc. off this. Option to have a place to hold small CO2 bottles. Options to have battery / car charger to mount to provide power for disconnected operation cooling. So that was kind of the point, is when you're at your house, you're going to plug 110 volt or 120 volt power into the beer Borghini, and you'll plug 110 or 220 into it, and it'll be running off that power, okay? Now, we'll talk about the controller and stuff also, but that's a different issue. So now if you take it to your neighbor's house, you can plug it into their house, right? If you take it to the beach, you can plug it into your car. That's an option. Or if your car is not close enough, what I'm thinking is I have to design a tray where I can put 12-volt batteries in here and have a couple 12-volt batteries off to calculate runtime, right? But maybe have a couple 12-volt batteries, and maybe even I'll have to look at, but solar is you're not going to run this thing off solar, I don't think. Although you never know. The maintenance charger, but by the time you get done converting solar with I'll look into it, but I'm not sure, right? Option to have battery, car charger to mount to provide power. I did that. Options for air cooling and water cooling is 2 choices. So I did a water cooler here. That's pretty. This is the beer Borghini version of it, okay? This is like the decked out fully. I got the heat pipes. I got the, you know what I mean? Other people don't build it this fancy. And they don't use a water cooler. They use just a simple air cooler, okay? So I'm not sure I want the beer Borghini to be, maybe we don't call it a beer Borghini. Maybe we call it a beer Yugo. I don't know if anybody remembers Yugos, but we'll call it a beer Yugo. Because that would be like the ghetto version with air cooling, okay? And small version for keg cooling only. Oh, okay. So, and I'm going to go get another beer here. We're going to set a timer real quick. Well, I'm not even going to set a timer. I'll set the timer. I'll play a loop of the other thing. But this is where I came up. You see, I was designing this little one, and then I came up with the idea, small version for keg cooling only. That's this. And then I said large version for fermenting as well as keg cooling. So I'm going to go grab another homebrew. And when I come back, we're going to talk about what this version here means, okay? So with that said, let me jump us. It'll be a couple minutes potentially. So let me do this. You'll have to forgive me. Come on. Okay, there we go. And I'll be right back. I'm back. So let's cancel that. Let's go back to the drawing. Okay, so, and I want to make sure everybody understands how I'm kind of doing this. I'm taking you through the organic process that I go through. I'm not sure I should. I'm not sure I should. By the way, my homebrew is so good. One thing about homebrewing is you actually enjoy the beer much better than I think you would otherwise, because you could taste all the flavors of the hops you put in it and all the ingredients and the energy you put into it. It's delicious. So, so the beer Borghini was the original design, Junior, the beer Borghini Junior. Now I didn't call it beer Borghini until recently. I was going to call it Beer Buddy, but there's too many Beer Buddies out there, so I was like, I got to come up with a unique name, which is where I invented Beer Borghini. So I designed this, and then I was like, and again, I want you to understand this cooling block wasn't here, and it had much different design, and but I was design, and I just want you to look at all the notes I have around here and different stuff, right? Attempt at a first logo for Beer Borghini. So I was designing this, and then I said, well, wait a minute. In this process of brewing, right? So the mashing, there's a burner under here, there's fire, okay? So you use heat during this process, okay? Now, lautering and sparging, you also use heat for these. So this is all hot, hot, hot. Now, the cooling step here, I bought a 10-pound bag of ice the last time for the batch of beer I'm drinking now. And I have it's not an immersion cooler, it's the opposite of an immersion cooler. But when I took the hot wort from here and I ran it through my cooler, it consumed 10 pounds of ice in like 1 minute. I mean, I was astounded. What I do is I put ice in I have my cooler, it's a coil inside of a bucket. The beer goes inside the coil, in the bucket. I have the ice in the bucket. I have salt in the bucket. I fill it up with water. I have a drill with a paint stirring attachment on it that I turn on. So it stirs this cold, cold, cold ice water. And the hot wort gets siphoned through the inside of the coil, okay? And I don't know how many feet, but I got a lot of feet inside of a 6-gallon bucket, I think it is. And literally the 10 pounds of ice melted in like 1 minute. It was astounding to me. And then it gets siphoned through the cooler right into the fermenter, so it stays sterile because it's all contained within that pipe. And when I first start running, I let it run kind of hot, and then I let it come hot so it sterilizes everything. Then I turn on the cooler once I got the first shot of hot through, if you understand what I'm saying. So anyway, and I'm redesigning this system, by the way, for the future, so it makes it easier because I want to brew more beer. This process is kind of cumbersome. It's a little bit cumbersome, and I'm trying to do some more automation and improvement on it. But when I looked at my process, I was like, okay, I was thinking about my keg that's outside. Oh, I need to cool it. That's what the Beer Borghini Junior was designed to solve. Oh, I want to cool down a keg of beer, and I want to take that keg of beer to the neighbor's house, right? Or to the beach or to wherever I want to go, right? That was kind of the concept of it. Then I said to myself, well, what about fermenting? You're supposed to control the temperature of your fermentation. Most homebrewers, or a lot of homebrewers, don't, right? Excuse me while I take another sip of my homebrew. A lot of homebrewers don't control the fermentation process because they don't have the equipment to do it. Or you have to buy a giant refrigerator for fermenting your beer, right? Which is, it's difficult, right? So I started thinking about it. I was like, okay, and then you get down here to kegging and conditioning and carbonating. You want to control your temperature here too, right? So it's like, you want to control the temperature here, you want to control the temperature here. I was designing the Beer Borghini Junior only for this last step here, right? Now, again, the reason I'm doing this is because the CO2 that's coming off is going to be fed to the plants that are growing, and the fish that are going to be giving off their sweet, sweet nitrates. Yeah, that's my nice fish. See, his poop is going to be used to grow the plants. Remember, plants have to have CO2, they have to have sunlight, they have to have nutrients, which the nutrients come from my little scissor fish. and water, right? And the water, the nutrients in the case of aquaponics is the same thing. So CryptoPonics gives all that, right? So I thought about it. I was like, oh, what if I made it bigger so I could get a fermenter in here, right? So then I started researching batch sizes. So I always make 5 gallons of beer at a time, right? So I went out on the internet, and it seems to me that it's pretty common that people will do 5-gallon batches. People will do 20 gallons as far as they'll cook a 20-gallon batch, but they turn it into a 30-gallon, or yeah, they turn it into like a 30-gallon, 25-gallon batch, right? Now I started researching, and it was like, how many kegs do I have? I have 4 5-gallon kegs. Now I can get more kegs. That's not a problem. That's so good. So I went on the internet, I started researching, and I found this beautiful little tank right here. So I'll show you this little tank. You're gonna love it. It's a cone bottom, 30-gallon cone bottom tank. It costs $100. That's it. So let's turn the web back on, and I'm gonna come back down here. I'll go to the new tab. I'll pull this up. It's a 30-gallon full drain inductor tank, okay? And I have the drawing downloaded and everything, and it gives you all the dimensions, and it weighs 15 pounds, okay? Well, there it says 15, here it says 16. You could get the bottom with a 1.5 inch female threaded or a 2 inch male threaded. I want the 2 inch male threaded for two reasons. Bigger is always better. And I thought about it. Male threaded is better. I don't want to jam something into there. I want the stuff to come out. So even though I don't need 2 inch, it's way too big, but it's a male threaded connection, which is better. So I'm going to get, it's $100. Now, it looks like it comes out of San Antonio, so it's going to have to be shipped, which, it's probably another 100 plus, right? So, or I'm going to make a trip over to San Antonio. We'll have to see how much gas. I'll have to calculate what my gas mileage would be. That would be 50 gallons of gas at $2 a gallon for $100 of transport. I'm probably driving. I'm going to get my sons, we'll get in the car and go have a nice road trip together. The tank is only 24 inches in diameter, and it's like 30 inches. Oh, I forgot to switch. 24 diameter, 33 inches in height, okay? I'm not going to get the stand. The stands are ridiculously priced. I'll be able to build my own stand, no problem. So let's switch back to my drawing. I'll get used to this, by the way, guys, as far as switching and stuff. So I found these sweet little tanks, and it was like the cone bottom. The really nice thing about the cone bottom for fermenting is all of the yeast, all of the solids, all of the gook goes on the bottom. And then what I'll do is I'll open the valve on the bottom. I'll have a valve down there, obviously, right? I'll open the valve. I'll let the crap out into a bucket, right? Oh, I'm going to put an air pump on this too, by the way. I'll put a little air pump on it and have it sealed. And then I'll put air pressure on it. So then I can use that air pressure. Now, just so everybody knows, 2.307 feet of water is equivalent to 1 psi, okay? And let me write that down real quick so everybody knows that. It's 2.307 feet of water. So if you have water in a bucket that's 2.307 feet tall equals 1 psig, okay? Now, most of these air pumps, if you think about it, most of the air pumps can pump 10 feet down. If you look at them, a lot of the air pumps can pump 10 feet deep. Like if you drop the air stone down in the water, it can pump 10 feet down, no problem. So if you could go 10 feet and 2.307 feet of water is a psig, 10 feet is going to be 3 point something psig. But a lot of what I'm trying to say is most of these little, even the tiny little aquarium air pumps put out 2 to 3 psig of pressure, right? Which 2 to 3 psig is going to get you 4.6 feet rise of your liquid, right? So 3 psig is going to get you 6.97 feet. So if you put 3 psig of pressure here with a little aquarium pump, you'll be able to lift this 7 feet high, right? If you follow me. Well, I don't need to lift it 7 feet high. I need to pump the garbage. What's going to happen in the bottom of this is you're going to get the yeast and gook down on the bottom, okay? And I'll open the valve and I'll pump it into a bucket. I'll open the valve just a little bit. Now, to do that, you have to have one of these panels removable, okay? So you're going to have to remove a panel, open the valve, or you could have automated valves too. I guess that's an option. Oh, that's so good. Open the valve, go into a bucket, get the garbage out of the bottom, right? And maybe you do that in a couple stages. Maybe you take half the garbage and you let it settle some more. You take half the garbage because there's this conditioning phase, right? Some of the conditioning can happen in your fermenter. So what I'm thinking is when I get a bunch of gook on the bottom, open the valve into a bucket, open the valve into the bucket, right? And then once you get to where you've got beer on the bottom, you put a keg here, you line your kegs up out here, whether you do your keg in the beer Borghini Junior, or obviously you can't do your kegs inside of the beer Borghini, right? Because your fermenter's in here. So you would have to line your kegs up outside here and just boom. And a keg is how tall is a keg? They're not very, 23 inches. This is what I'm saying. That's 2 feet. That's 2 feet. So it would take 2 feet of, that's 1 PSIG. The smallest of the small aquarium air pumps put out that much power. So effectively on the top of this, I'm going to have aquarium air pump putting pressure in, pressuring it down into the kegs, right? Boom, boom, boom. I fill, if I have 20 gallons in here, I can fill 4 kegs, right? And I'm thinking, you can make any size batch you want. So I'm thinking about making 15-gallon batches, okay? Which means I've been looking for a 20-gallon mash kettle because I would like to have 5 gallons of extra space, right? So I've been shopping for a 20-gallon mash kettle so I can make a 15-gallon. Although I don't think I need 15. You're not actually going to make 15 gallons of mash, but I've been looking for a 20-gallon mash kettle anyway. I guess I think through it, I could probably get a 15-gallon mash kettle because you make 10 gallons of mash, and by the time you get over to the fermenter and you add water, blah, 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 maybe you get to 15 gallons, right? So 15 gallons, this thing's a 30-gallon fermenter. That'd be kind of cool, right? But I could make a double batch if I wanted to. Literally, and that's what I'm trying to say is I could cook with a 20-gallon. I could go. I don't want to go to. I don't want to go to 20. I don't want to go to 30 gallons because this. I calculated this. It holds like 32 gallons from my calculation. Okay, right to the brim. Now, 25 gallons maybe, right? So, but 20. Then I got to get kegs for 25 gallons, which is 5 times 5 is 25 gallons. So 5 kegs maybe, right? But now I'm starting to make a lot of beer, and remember the graph with carbon dioxide, the carbon dioxide released from fermenting 5 gallons? Imagine that was 15, wasn't that 15 cubic feet? So if you multiply that by 5, you're going to get 60 cubic feet of carbon dioxide coming off from fermenting that. It's going to be a tremendous amount. Now, on this keg, I thought about putting like side draws and stuff, but then I was like, no. I'm going to push the garbage out the bottom, and then I'm going to push the beer out the bottom. You know what I'm saying? Once the garbage is out the bottom, I can push the beer out the bottom. You know what I mean? So, and I got to make sure I just don't get in a rush to do it because I might push stuff out the bottom and then I might have to let it sit for a bit and then push the rest out the bottom. Something like that. We'll see how it works. Okay? So, back to the beer Borghini. So, I found this really cool 30-gallon cone bottom tank. And you see, I said we'll have 1/2 inch uniseals on the cone. That's I don't think I'm doing that anymore. My original thought was putting, and I'll just draw this kind of roughly here, and let's do it to scale. 0.5 inches, right? My original thought was somewhere in here is going to be a sludge line, right? I don't know where it's going to be. We'll draw a couple sludge lines. Somewhere in here, I don't know where, but somewhere in here is going to be sludgy beer, right? Well, it's going to be the yeast and stuff that settles on the bottom. That's just how it works, okay? What I was thinking about was what I might want to do, and I still might, well, I might end up doing it because you could get a thing called a uniseal, okay? And what it does, you cut a hole in the side of your cone, and you put the uniseal in there, and then you can poke a pipe into it, okay? And it seals. It's a tight seal. So I'm not going to draw the uniseal, but then you would put a valve on this, okay? So you would, let's say that's the sludge line, but let's say it's not. I'll show. Come on now. So I would do something like this, right? Here's what I was thinking I would do. Now then I kind of convinced myself, I don't need to do that. But so I would put 1, 2, 3 uniseals. I'd drill 3 holes, kind of spaced approximately at these levels, right? And then now from this, I'm going to have to kind of say, well, how much sludge do I usually get? And when I say sludge, it's the yeast and the, non-converted stuff. And based on that, what level do I think it would be in the cone based on volume calculations, right? And then I would drill a hole. I'd put a uniseal in here. I would put a piece of pipe in here. And then I would put a valve on here, okay? So, and I would want it to be as close, I would want it to be really stubby and short and have the valve right here. So it was as short as possible, if you understand what I'm saying. Now, okay, I'll explain that later. So I would have 1, 2, 3 valves. Now, if the sludge line was here, for example, then I would take good beer off at this point, if you're following me. And see, I kind of, talking through this, I like this idea. There's something just naturally good about this. My idea about draining it out the bottom, you know, the heavier sludgy stuff, I open a valve and it pushes out the bottom. I just think that some of the stuff is going to cling to the wall still, right? And so I don't think that's going to be that clean of a break, right? Whereas this way, if you let the stuff sit long enough, if you let it sit for a while, you're going to, you see like the yeast level will be here or the yeast level will be here. So let's argue that's where the yeast level is. So this first valve you would never open. But the second valve, if you open the second valve, that's not the yeast level, right? So if you open this valve here, you get nothing but just clear beer above here, right? It's all clear beer coming down. So, and you're not disturbing this. So this is the really, I'm probably going to do this. Now, when you clean this thing, you're going to have to take the 30-gallon fermenter. Remember, it only weighs 16 pounds empty, right? So you'll take this thing out of here, and you'll pull these things out of here, and you'll clean all this pipe, and you'll clean the valves, and everything will be clean. You know what I mean? It'll be sanitary. So now it's going to go from the fermenter right into the kegs with some air pressure, right? Or better yet, CO2 pressure. I don't want to actually use air because air is bad for beer. You want to use CO2, so maybe I'll use CO2 to pressure it out, right? I can't get over how good that homebrew is. Oh, I can't wait to brew more. It's like a meal, and if you drink, 1 or 2 beers, you don't get drunk. It's there's nutrition in beer. The history of beer is amazing. I'm gonna do an episode soon on the history of beer too, because whatever. I'm too distracted. I'm on like ADHD. So we get the beer out of the fermenter, right? And into kegs. Now, while it's fermenting, so from mashing, eventually I'll be doing full grain recipes. So I'm going to do lautering and I'm going to do sparging. Okay. Now, to do that, you need larger kettles. But eventually, you take your kettles and they all go through the cooler, which I still love my cooler design. I just have to improve it some more. I want to have a circulating water system instead of a batch water system. And I have to have a bigger reservoir of ice water. That's the other thing I need. So, and I know exactly how I'm going to do it. It'll be like the best beer design in the world. So you take it from mastering, lautering and sparging, and you run it through the cooler, goes into the fermenter. I got this beautiful 30-gallon fermenter here, and that's all dimensional. And from the top, this is dimensional. So ferment, let's say 10 days, 12 days, 14 days, whatever the number is. Keep a CO2 pad on top of it, okay? Once the fermentation's done, then as we just discussed, I can transfer it using CO2 pressure. I said air pump. I'm not using an air pump. Maybe I will. Maybe I will. Maybe I won't. Maybe I'll use CO2 pressure. And pressure it out of here into kegs, right? Keg. Now I got these beautiful kegs full of beer. I take the fermenter out of the beer Borghini, rip this baby out of here, and look, I could fit 5 kegs in here. 5 kegs. Five of those kegs. The ball lock kegs, I probably could fit like more. But easily I could fit 5 pin lock kegs, okay? I first started off, I have a 4 design, I have a 5. I was like, well, let me see if I can fit 5 in there. And so I was playing around, maybe I could fit 6 in here. I'll bet you money if I really start squinching them in here, I'm not going to do it. That's not what I'm here for. I bet I can fit 6 in here. Ball lock kegs, I bet I could probably fit 8 ball lock kegs because they're smaller. They're 8 1/4 inches instead of 9 inches, right? So how many kegs can you fit in here? A lot. So you ferment a big batch of beer, you get 25 gallons, you fill 5 kegs, bam, I got 5 kegs of beer, right? Now look at this. Look at this. I started designing the systems. So as we talked about on the left side and the right side, I plan on putting 12715 Peltier modules, okay? They run. Now, I have to have a power supply unit, okay? I've shopped this out already. I got one that'll work. So this doesn't look right. This plug is going to be mounted over here. That's what I'm saying. This, I have to fix up the designs and stuff, but this plug will be mounted right here inside of the unit. So you'll have to open up like an access door or something like that, and you'll have to put a plug into here to provide power to this, if you understand what I'm saying, right? Okay? And I'm going to have a male to female plug. Let me think about that. Because an extension cord typically would bring the positive plugs into your wall. It comes with a female. So I'm going to have a male to male plug. Yep, I'll have to have a male to male plug, okay? That's how I'm going to do it. It's going to be a male to male plug, which may seem strange, but that's how I have my generator set up too. I used to have an emergency generator set up with male to male plug. I could, I'm going to have to pause and go get another glass. Anyway, yeah, you'd have a male to male plug, okay? So that'll come with the kit. Well, I say kit. This is one of the things I'm considering too. Do I do this just for myself, or do I actually build this commercially? Because it's going to be so cool, right? Now, the electricity comes in here, then the electricity goes through here, which is just going to be a main power switch. So this is going to be a power switch that is, and this might actually go here. Yes. See, a lot of the stuff I've just thrown in here, but I need to think through it better, okay? So and this, remember, this isn't going to be here, it's going to be up here. So we'll have a male-to-male cord, or I actually might keep it back here with the male-to-male plug, and then your extension cord, you'll bring a plug in here, plug it in here, boom, plug it in here. It goes through the main power switch, so you can shut everything off with this switch. There'll be some type of enclosure here that protects this. Well, if I'm going to have an enclosure, I should put these switches here then, right? Absolutely. Okay, so I'm going to have some type of enclosure here that protects us from the weather. This PSU is underneath. So these 2 switches, these 3 switches, and this thing, this controller, are up top. The PSU, the outlet, and the male-to-male are inside, okay, inside a cabinet. Okay? Yeah. Now, well, we have to have some venting. We're going to have some vent holes. So I might have a fan over here blowing, a low voltage fan blowing air out and coming in or something too, okay? We'll have to figure that out. So power comes in, goes into the PSU. The PSU takes 110 voltage, breaks it down to 12 volts, and possibly, no, just 12 volts right now. That's all I need. That 12 volts is going to do a couple things. It's going to go through these switches here, which those are called maintenance cooling switches, top and bottom. So I'll have 2 switches here for maintenance cooling. And then I'm going to have, and you can turn them on or off. And then I'm going to have, now all of it can be turned off with this switch, but I'm also going to have this thing, which is a controller. It's a temperature controller, the same as Soren had demonstrated, right? So I just thought about something because I haven't seen a viewer in a while. Let me just make sure that I'm still streaming. Oh, let me grab my phone. Oh. Anyway, that controller is going to be the same as Soren had, okay? Let me pull up the web real quick. Come on now. Really? You know, it's Murphy's Law. It's always the last tab you go to. It's coming along. So I'm gonna go to DLive. We'll check DLive. If you're watching me, I recommend you go. If you watch this, please go to dlive.com and watch it over there. I turned DLive on. DLive has a thing where you can store videos for 3 days now. No, it's not dlive.com. It's dlive.tv. dlive.com is some stupid thing. Okay, and how do I search here? Come on. Oh, come on. I did not want to click there. No. Okay. Chatting, blah, blah, blah. Let's see if I can click there. It is. Let me search. Where do you search? I'm on mobile, so it's there's a crypto category. I know that. That's what I should be streaming under. Oh, they got an app. They want me to download an app. But we'll see. We'll see. Just hang in there, guys. Give me 1 second, please. They got a raft channel? I'm not going to stream as much as I want to play games again. It's so tempting. I'm not going to do it. How do I search? See, this is close. No. Home? Oh my God, that was home like home. Okay, what's that? Contact, blah, 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 blah. I mean, I could see that, but I don't see Call of Duty. This is painful. This is like really, really, I can't, on mobile, I can't get to the search button. Why can't I get to the search? Okay, that's the internet stuff. That's not. Oh God, why can't they make things like YouTube? Actually, for all my bitching about YouTube, categories all. But I don't want all categories. I want to be able to search a category. Why don't you let me just search a freaking category? Oh, this is painful. I got to check this though. Whatever. Let's go to YouTube then. Because I should have done that from the beginning. It's ignorant. Look at YouTube has a little search thing. So I could search CryptoPonics on YouTube. CryptoPonics, P-O-N-I-C-S. And I need to get more views, guys, so that we can, so CryptoPonics actually ads. Oh yeah, okay. It says let me make sure it says live now. For beer, you want to use CO2, so maybe I'll use CO2 to pressure it out, right? ICS. Looks like it has a big lag, but it's streaming. It's streaming. Okay, good. Excellent. So let's move on. Let me have another drink. I think what's going to be the really fun thing is while I'm doing my CryptoPonics, I'm also going to be homebrewing. And boy, that's going to be fun. So back to, okay, we were talking about the power. So effectively, I'm going to have a male-to-male connection connected into here. Maybe I'll just have the male connection connected here without the outlet and just have it wired in. So it's just a male connection that you hook your power into. Yes. I mean, that makes perfect sense, right? I also am going to need a 12-volt connection and a battery connection, which I talked about. So I got the main power switch. I got these maintenance cooling switches. And what they control is one switch will control the, and now I know I have 5, so I'm actually going to think about using them all. One switch is going to control the top Peltier device that I was planning, and then I was planning on putting a Peltier on the bottom. So that's one on the right side, one on the left side, one on the top side, one on the bottom side, and then I can have one on the back, we'll call it. So ultimately I can have 5 Peltiers. Now, my cooling system will need to handle it, obviously, if I run all 5, right? But I'll need to play with it. I don't know what I need. This is my first design. I've done some calculations, but it's, it is what it is. It's not a perfect science, right? So the power comes in here, the main power comes through this switch, goes to the PSU. You shut this switch off, you've shut all your power off. You turn this switch on, you turn all the stuff on. The maintenance switches, you can turn them on or off, right? They're going to be mechanical switches, so I think by default they'll be on, but you can leave them in whatever state you want. Maintenance cooling switches, top and bottom, right? Oh, yes. So, and then we got this temperature controller, which this is the exact same controller that Sorin was using. Now it's going to work in Celsius, so I think I'm going to have a little table up here for conversion from Celsius to Fahrenheit for the English people like myself. But what's really cool is, what I like about this thing is you set a upper level and a bottom level of your cooling, and then this is your current temperature. And what it does is, like you saw in the video, is you can say 17, at 17 Celsius I want you to kick on, and at 15 Celsius I want you to kick off. So you can have like a 2 degrees Celsius range there that it won't run at all, right? And then what Soren was saying, which I really, really, really liked his idea, was that you have these maintenance Peltiers. He had one maintenance Peltier, had one working. I'm potentially going to have more because I got a much bigger system, right? I mean, literally, he was using 12-ounce soda cans. I'm sorry, soda cans. I'm drinking soda, by the way, too. I forgot to mention that. It was homebrewed soda. So in his system, he had 1 and 1. In my system, I'm going to have, who knows what, right? So, and one of the differences, if we look at this, so the power, and then these switches will power the Peltier on top and the Peltier on bottom. And then, in my opinion, the temperature controller is going to control the right side and the left side Peltier, the big Peltiers, okay? Now, I think I might have to do it with a relay. I haven't totally looked into the design, but I think this only handles 10 amps. And these Peltiers can draw more than 10 amps. So the way I think it has to be done is that this temperature controller controls a relay, and the relay will provide power from the PSU straight to the Peltiers through the relay, but that the temperature controller is not actually providing the relay power, if you will. Okay, I think that's how it goes. Okay, so now the pump doesn't use that much. It's like 5 or 6 watts or something. It pumps a fairly good amount. I calculated with the pump going through here. Let me see if I can show you that calculation real quick. Is it here? Let me just look real quick, guys, before I switch. I don't want to switch before I find my calcs. Yeah, my calcs are not visible to me no, I don't see them. Okay, so let's go back here. But yes, I calculated the pump, and I calculated with a 5-degree temperature rise through the temperature cooling here. So what I'm saying is that there's going to be a 5-degree Fahrenheit. The water coming through here, I expect to heat up 5 degrees. Come in here, cool down 5 degrees. Come through here, heat up 5 degrees, cool down 5 degrees. And again, this isn't going to be here. This can be facing this way, blowing hot air to the top of the drawing. Okay? And the controller, when it needs to cool more, it's going to turn the big Peltiers on. And what I'll have to figure out is how much for maintenance. I'm going to use this unit to try to prove how I need to design these things, right? So what I'll do, because none of this is proven science, okay? But what I'll do is I will figure out what size Peltiers I need for maintenance. I'll figure out what size Peltiers are appropriate for cooling, because if I could cool, let's say I could cool let's say I transfer into the fermenter, right? So I mash, I go through cooling, I go in the fermenter, and let's say I could take this from 140 degrees down to 60. Let's say I could do that in 2 hours, right? Well, that's really, really good cooling then, right? For 25 gallons, let's say. And I'll do tests that way, right? I'll fill this thing up with water, for example, and I can just cool or heat the water, you know what I mean? Not heat, but cool. So, but basically I'll figure out, well, if I could, to me, if I could cool this fermenter from like 120 down to like 40 degrees, if I could do that in like 4 hours, that's great, right? If I can't do it in 4 hours, well, then it takes longer than 4 hours. But if I could do it in like 1 hour, then my Peltiers are too big, if you follow what I'm saying. So that's what I have to kind of determine. I want to build the system, do the testing, determine what I need, and get it from there. So the system I have here now on the inside of the inside of the beer Borghini, it's the same exact design. So I got the plywood, right? I got the plywood going around. I got 4 pieces of plywood going around. I have 2 inches of insulation going around that. And you'll see what I plan on doing with these heat pipes is I plan on covering them with plastic, rectangular plastic pieces. And then I plan on getting some, what's it called, expanding polyurethane foam. You mix it and it's like a polymer and it expands on its own. So these pipes will all be filled with foam insulation, okay? This whole block here will be filled, all that will be filled with insulation, the whole block. And then obviously I have to cut holes through the insulation for it to poke it on the side, right? Now, where it comes in on the inside of the beer Borghini, check this out. These are 30 millimeter fans that I found, the actual pictures of them, and they're scaled to 30 millimeters. But there's this thing which is beautiful. This is 150 millimeters by 80 millimeters by 27 millimeters, and it's an aluminum heat sink. And what I'm going to do is I'm going to attach it to these copper, this is a copper block. So that right there is a piece of copper. And then the heat sinks, no, what did I call these? Copper heat pipes? Yeah, those are copper heat pipes. Those things are these things, which are these things, okay? And I know what diameter dowel to bend them on. I know how much of them I need. And I originally designed them as circular, 3 millimeter circular, but they're being changed to 1/8 inch tubular. Well, not tubular, solid. It's a 1/8 inch rod, which is like 3.1 something millimeters. So they're bigger and they're square. So by being square, they have even more area for heat transfer. So the thought is you got your Peltier here, you got the cold side over here, you have this, what do I call these again? Heat rods? Cooling rods? What did I call them? Come on. Heat pipes. I call them heat pipes even though they're cooling. Okay? But we'll call them heat pipes. So I got these heat pipes coming down. And I got the distances. You look here, I got the distances of every heat pipe. So it's 3 inches of straight run and it's 2.4 on the curved part for this circle. It's, 3 inches for the straight run and 1.8 inches for the curved part. So I actually measured the outer circumference of all these on the bending. Okay, so we have the heat pipes, and they're welded to copper on this end, and they're welded to copper on this end. They're attached with heat conducting grease to the Peltier, so the cold is transferred. Remember, the hot's going through here, and again, you have a heat conducting grease to transfer the hot side to the water block, right? And then this copper plate will be heat conducted to this aluminum plate. Okay? Now, this aluminum plate is huge. And I was like, oh, this is so cool. So literally you could have, and now that I actually think about it, I can have 1, 2, 3, 4, 5 of these coming out like this, connecting into these blocks, right? 4 screws per copper plate going through. And I got to get all these dimensions down and stuff. And then if you look at the fans, Control Z, you look at the fans, if you mount the fans on rails, just have 2 rails, one there and one there, and tap some threaded holes in and mount them up a little bit. Look at how perfect the fans blow down on that giant cooling block, right? So that's like perfect. And then the power for these will come through the, through the top, through the insulation or whatever, over to the power supply, right? Now I was thinking about it is, if this top one's a maintenance fan, a maintenance cooler, and the bottom one's a maintenance cooler, maybe I put this fan with these switches, maybe not. Maybe I just run, because these things run with like very 0.08 amps, I think it was. Very, very low current flow, right? Because they're tiny. So, but they got really good reviews, really good ratings. So that's that system. The hot system we talked about. I might need a second radiator potentially, but I don't think so. With the circulation rates I done, I calculated, I think my water flow rate's like, I think I calculated like 5 or 6 times more than I actually need. So I think my water flow is perfectly fine. I think I'm going to have more water than I actually need. So I said I'm going to have a 5-degree delta change. I expect what I was targeting was to come in, heat up 5 degrees, come in, cool down 5 degrees. But the flow rate for that was way lower than the pump puts out. So the pump's going to be flowing more water. So the change in temperature will be even less, right? So the thought here is, now this reservoir, I'll fill it up until I get the whole system full of, I say water, I'm not going to use water. I'm going to use like ethylene glycol or some type of cooling liquid. And I'll fill the reservoir up, get it running, get it circulating, get that fine. Down here, I found these really cool latches, which I don't need to show you. But what I'm thinking about is the door on the bottom of this thing. Remember I said you have to remove one of the surfaces? I'm thinking that this, you see how I changed the design? Oh, come on. That can be attached to a door that latches this way. So the latches cannot be this way. They should be this way to hold it on, right? So I have to change the design down here so that the latches are facing north-south on the drawing, and it'll pull the door into the unit. You know what I'm saying? That way, if you're transporting it, something like that, 30 gallons, 25 gallons in here. Let's call it 30 gallons. Let's say 1, 2, 3, 4, 5. 5 times 5, 25 gallons. 25 times 8 is what? 125 pounds, right? No. They're 40 pounds each. It's 8 pounds per 40 pounds times 5 is 200 pounds. So this thing's going to have a lot of weight in it, right? And the beer Borghini is going to have 4 wheels on it. It's not going to just have 2 wheels. It's going to have 4 casters, like really nice casters with locks and maybe a little handholds or whatever. Because this thing's only 2 foot by 2 foot. Well, maybe a little bigger than that. What was the dimension? 2 foot, 3.5 inches. Well, that's there. So it's a little bigger now. See, I didn't update that. Three foot, 2.25 inches. Yeah, it's a little over 3 foot. Now the width is 2 foot, whatever the other number still was. I didn't change that dimension at all. But that's 2 foot, 7.5 inches. But that's not the full dimension. So it's 3 foot by 3 foot roughly, okay? So, I mean, we're starting to get bigger to where it's not, this unit, in my opinion, and maybe I'm thinking about it, is maybe I have to be able to transfer the cooling block, because this cooling block's pretty expensive, okay? The most expensive part, I mean, literally we're talking about plywood that's cheap, insulation, the insulation's cheap, the 2x4s are cheap, the PSU's cheap, the controller's cheap, the switches are cheap, the fan, the radio, everything's, the most expensive thing is this, and what is it, $41 for the heat pipes. The aluminum blocks are $10 a throw, I think, so that's $20. This is your most expensive piece right here, your cooling, heating, and the Peltier pieces. So maybe I make this as a, I don't want to make that removable. Again, the thing I like about the Beer Borghini Junior, you can take it to the beach. You can literally take it to the beach and have a nice party with it. Now, the Beer Borghini Junior, if it had charging station, USB ports for charging, that'd be cool. Yeah, I don't know how transportable this one is, right? That's what I'm trying to get to. And why would you need to transport? Like for my house, for here, this is pretty cool, right? Because I could brew like a bunch of beer. I could put all that CO2, that juicy CO2 that the plants crave, right? If we want to coin a idiocracy, it's like Brando. That's what I'm going to call this. CO2 is the new Brando. No, don't make that a capital. I wanted that small. The new Brando. Brando. I think that's how Brando is spelled, right? Because it's what plants crave. So plants say yummy yum. And if I make bigger batches, like I just made 5 gallons of homebrew, to make 20 gallons, it's the same work. That's what I'm saying. To make 15 gallons, it's the same work. It's just you deal with a bigger pot, you deal with a bigger fermenter, right? So that's kind of what I'm trying to get after. Now the plants need the Brando. So they're like, oh, give me the Brando. And if I'm making 15 gallons, it's 3 times the CO2 that we measured. And I got to get that set up to where I can measure that CO2 level, right? Controlling the temperature of fermentation, it's not required, quote unquote, but boy, it makes better beer, right? So this is going to really take my beer brewing to the next level. Keg conditioning and carbonating inside of the Beer Borghini to the next level again, right? So once you've done everything, and again, you got to think about the Beer Borghini, it's going to have a bottom on it, like we talked about with insulation and stuff on the bottom, obviously, right? And then it's going to have a lid on it. That now with the Beer Borghini, if I have 5 kegs in here, I need 5 taps. Just the cost of the taps. Taps are like $20 a throw, right? So if I have 5 kegs, I have 5 taps. That's $100, right? But I could have a light beer, I could have a porter, I could have a IPA, I could have a stout, and I could have an ale in there. I mean, how freaking awesome would that be? To have, 1 keg of each type of beer. Now, you say that, whoa, that's not quite true, because then how would I make those? But I might have a couple Beer Borghinis, and I don't know. I'll have to figure that out, because to have 5 different brew types means you had to do 5 brews, which means, what does that mean? That means I'm making 5-gallon batches, which sucks again. And that's what this came down to. I made 5 gallons of beer, and I said to myself, boy, wouldn't it be nice to make 15 gallons of beer, right? Do it one time. So anyway, that's the Beer Borghini. Its current design. I got a lot of work left to do. I say I have a lot. I've come up with a lot of the design, but I have some calculations. I have some verification left. My 30-gallon conical bottom plastic, food grade plastic tank. I love it. I love it. I think I'm going to do these bulkheads in here, 1/2 inch. The smaller the better, actually. So yeah, but I think the smallest I can go on that's 1/2 inch. And I might not do uniseals. I might actually do bulkheads, which are a much more secure way of doing this. Uniseals actually screw on, and they have screwed connections and stuff like that. And you don't have to worry, there's no leakage, et cetera, et cetera. So I might do that. The Peltiers, I'm really kind of excited. Again, my efficiency, I expect my efficiency to be between 25% and 50% will be my efficiency, somewhere in that range. I'm going to make these cooling blocks by hand. I'm going to video that when I do them. I got these parts, this part right here, I got these all spec'd out. I got the order parts for them. So I know how to do that. I know how to cut this copper. I have to order some copper sheeting. And then I'm going to make these pieces. But I have, if you look, I got all the dimensions of everything. And so that's going to be a 2x2x2 cube of copper. And I'll be able to do that. The heat pipes, the bending of the heat pipes, I got all that kind of down. The aluminum heat sinks. Now, the one thing I'm a little bit, after talking through this with everybody that's watched this, whoever does, I have to research copper touching aluminum and see what the difference in metals is there, right? And this concept of bringing in little pictures, I really kind of like that idea. Now this is going to change orientation. The little controller I really like. I mean, look at that. Look how cool that is. And that's dimension to the actual specs of the item. And I got to get some type of environmental enclosure over there so that if you're out at the beach and it starts raining, it doesn't just short circuit everything, right? Anyway, I think that's the end of that, right? Let me look here. I want to wrap up with what? Let's check our crypto prices and we will wrap this episode up. I wanted to cover, the main thing I wanted to cover was my beer Borghini, I think. And I also wanted to cover Soren's video and how I used equations and I back calculated his efficiency. So that was kind of important to me. Okay. Oh, let's look at this real quick. Let me update it real quick. I got to turn a couple things on, so I might as well just do it myself. I'll be right there. Hold up. I'm going to update my crypto calculator to show you how my hashing's been going. It's been terrible. 7119. Okay. Okay, so let me turn I got to go here. First thing I want to show you is I just updated this. I went to the web and I got you can see 2100, 9 o'clock my time. That's 9 o'clock my time. I got the current coin balance I have. So and there's the current price of the crypto. So 2.24 coins I've mined in 0.51 of a day. So that tells you it's going to be 4 plus 4.37 coins per day. And you look at the numbers. My best is 5.72, right? I'm at 4.37. My worst, red like danger, 1 standard deviation out is 4.16. So I'm 4.05, 4.16 is terrible, right? I'm at and that 4.05 was I had 3 hours down that day. I'm at 4.37. So my income per day right now is $3.11, 31 cents a GPU. It's horrible. That's before electricity. So you take the electricity cost off, my entire mining is 31 cents I'm making, quote unquote, right? 3 cents per GPU. Absolutely atrocious. 3 cents, yesterday was 3 cents, today's 3 cents. The day before was 2 cents. I said this entire day's earnings were down. I was watching it throughout the day. It was terrible. The day before that, though, look, 9 cents which is still terrible. Again, my goal isn't to be mining this stuff for 71 cents. It's to sell it when it's $1.65, like I showed you. And if I could sell it for $1.60, I make $7, $8 a day. You know what I'm saying? But my main goal is to really optimize my coins per day. I could care less about and I say that I could care less about the income per day, really. I try to watch, and that's why I got green and red on these. I try to watch my coins per day, because eventually, when I hodl and the prices come back, I'll be able to sell for $1.60, and that's where I make the real cash. Okay, so okay, with that, let's go look at the web real quick. I gotta fix this. There we go. Or I gotta not fix it. I gotta figure out how it works, right? So here was where I picked off my price. This is what I'm saying. See, my hash rate is 319. If you go look at the calculators, it says I should be about 330. I typically am about 330. I've been down. You see, I've been down a little bit lately, but back here I was up. So I don't really understand. I've always thought when the difficulty goes down, let's come here. I'll show you the difficulty. The orange line is the difficulty of the coin. Okay, so when the difficulty goes up, you're supposed to hash slower, okay? And maybe that's what this is actually, if I look at this, because it's saying difficulty went up. You're going to do worse, right? So difficulty right now is at 419 million, I think that is, yep. And I've seen this as up to 700 million when crypto was better just a few months ago. Well, we're at 700 megasouls, so there's a lot of people hashing this coin right now. So let's go look at what to mine real quick. That might be what's going on here. Let's go look at what to mine. So let's click here. Where's what to mine? Where are you? There you are. Okay, so I have a 1070 Ti. I got one. I got 1070s. I got 1060 and a 970 mining, which is the same as kind of two 1060s. 0.1 for electricity, close enough. I'm a little under that, but close enough. And see, I hate these calculators because they're always off. Does it show me what I should be hashing? There's some website or some place. It's right here. Yeah, here. See, it says that I should be hashing 338 souls. It says hash per second, but it's souls per second. And I should be using 1220 watts. Okay, so let's check that real quick. Let's check the watts. Let me hold up 1 second. So, because I've derated my stuff tremendously, okay? 1, 2, 3. Okay, and that might be part of what's going on here too. My hash rate's a little down. I actually am only, my rigs are using less. My rigs are using 1126 watts. And I'm sorry I'm not sure. Here, let me show you. There. I'll zoom in. These are actual numbers from my rigs. So rig 1, the 51070s are reporting 565. I got these running at 67% on the power. A lot of people will run them at 75%. I run them at 67%. And it gets me even lower wattage. The same here, all my cards, well, my 1070s are running 67 and the 1060 and the 970 have to run at different numbers. And then the 1070 Ti is running at 120 watts, which totals up to 1126, right? So I'm running at 1126. Now, I do know that if I go and I increase these, I get more hash. I know that, right? But the problem is that I'm not really paying for electricity as it is, right? So you can see I'm using $100 electricity there. What that says is what? Okay, so in this one, what I did, and I finally braved up to do it, is I said 80% efficiency on my power supplies. And so instead of 1126 watts, I'm saying it's actually using 1407 watts for all of that, right? And then times 24 hours divided by 1,000, I get kilowatt hours. And then 99 I actually get 9.5, but I said whatever, close enough. And multiply those two gives me $3.34 per day, 30 days in a month, $100. So I have to make 334 in a day, right? And if I came here, I'm making 308 right now. See, what this doesn't take into account is the loss of efficiency of the power supply unit. So it's 308, but if I sell the coins for more, you know what I'm saying? Then I've made my money, right? And the time changed on this a little bit too. So let me update that, because what happens is as soon as you change anything on that spreadsheet, it updates, right? So let me see if that's changed at all. 636245. Nope. So that didn't change at all. 7072. Okay. 7072. This changed. This changes all the time. I mean, the coin price changes all the time. So 334, I said I had to make. I'm making 306. I'm losing per day 30 cents if I sold those coins today. Now, I don't sell them today. I'm going to sell them when they are $1.50. Okay. Oh, I doubled my money. You see what I'm saying? Now you're going to say, oh, but it's never going to get to $1.50. That we can argue that. Okay. Okay. Back to the web. Let's wrap this episode up. Back to the web. So what to mine? These calculators are the 338. What was I doing? 317, but 1220 instead of 1148 or something. I'm using less wattage, so I'm saving on the electricity, but I'm not hashing quite as much. Fair enough. And it goes through and it says Grin. I looked at this. I literally went to a Grin calculator. It's I can't make money on this. It's wrong. These calculators are wrong. They try steering people in wrong directions, which I hate. Like here, it's trying to tell me that my card should make me $1.12 profit when I just proved that they're losing money, right? So, but I don't understand why my hash rate's so high. Why are so many people hashing this is what I was trying to look at. And you see Nice Hash has Beam, and that's a really big hashing rate, but they're losing money too. I mean, they're down on the list, right? So a lot of people will come to what to mine. They'll say, oh, I'm going to mine Grin today, or you know what I mean? But you see Grin and Swap, $1.94, $1.18, $1.12. I mean, $1.94 is a lot more than $1.12. So for the average person just coming here, they're going to start mining Grin, right? So I don't understand the high hash rate, but whatever. Okay, so we'll wrap that up. Come over to Soren, show him some love, watch his videos. It's pretty cool. I actually communicated, I sent him a message via email through his YouTube channel, and he responded to me, and that was very, very nice. I'm actually I don't need to talk to him anymore. I figured out what I need. Oh, speaking of which, before I go, one thing I want to ask anyone for electrical help, if you're watching this, there's an item I found which I think I want to build. Okay, so this item right here. This is what I actually want. When I asked for electrical help, okay, what this does, this is its own little mini power supply, okay? So if we come over here, this takes in 12 volts, and it puts out 12 volts, and it puts out 3.3 volts, it puts out 12 volts, it puts out 5 volts, and it puts out 5 volts. But it also puts out negative 12 volts as well. I want to make absolutely sure I'm speaking correctly on this. Yeah, right here. Here's the table. So it puts out 300 watts. It's a 300 watt mini ITX. Instead of an ATX, they call them ITX, I guess. 300 watt Pico ATX, or a mini, and it looks ugly, okay? But it does exactly what I've been looking for it to do. So what it does, input voltage, it takes in 12 volt. You remember I talked about, I bought a 92% efficient HP server supply. that has a breakout board with 16 6-pin outputs. Okay? So what this one does is it takes voltage from 12 volts. It takes 20 amps of current. It's got a 85% plus efficiency, which is pretty cool. And it puts out 3.3 volt. And it tells you right here, 6 amps average, 8 amp peak is what it can do, okay? 5 volt VSB, blah, 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 5 volt, 12 volt, and negative 12 volt. And you remember I said that it's not much power, right? Amps, current, max voltage. It doesn't show watts on here, which we can figure out, right? It's wave watts equal amps times volts. And I got amps and I got volts, right? So I could calculate the amp wattage, but he's got the wattage. Working temperature, blah 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 blah. Yeah. So this machine does what I've been. Oh, it's a 300 watt power supply is what it is, but it's a 12 volt power supply. It doesn't need. You don't have to plug it into the wall. You don't have to, right? And when I look at it, it has the cables it comes with. I hate how you do that. So I see the 24 pin. The 24 pin is this big mother, okay? And on the other end, you see it's got the 24 pin. So what they do is they plug into here the big white 20 plus 4 pin. They plug the 24 pin into there, and then it plugs into your motherboard 24 pin, okay? Now, if you look at this right side looks like it plugs into the power supply, the little PCB here, printed circuit board, right? So this right side looks like it plugs into this 24 pin, and it comes down to this end, and then he branches off this way from the 24 pin, and he provides different cables down here, okay? Now, he provides a Molex connector, he provides a SATA connector, he provides a 4-pin, but he provides the wrong 4-pin. Somebody down in the comments said, oh, you're providing a 4-pin, but it's not the motherboard 4-pin. It's just a generic. But if I look at it, he provides the right cables for the 4-pin. I think it's just the wrong connector. They're not giving you right EPS. It's called the EPS 4-pin. He's not giving you the EPS 4-pin. According to one of the users, he's giving you just some other 4-pin, I guess. And if I look here, what does this look like? This looks like a Molex to me. That looks like a Molex. That looks like a SATA maybe, right? When I look at this little connector here, I see red, I see black, and I see yellow. If that's Molex, I don't know. But comments are all positive. He's got 4 stars. Everybody loves this thing. The good comments. I mean, it's like really good comments. And it does exactly what I was saying is I could take from my HP power supply, I can provide 12 volt inlet. Now, how do you get power in? It's this stupid cable on the bottom, okay? So if you look at the cable on the bottom, he has some type of weird ass connector here. And it comes like this, and it comes into this connector on the end. Now, the connector on the end hooks up like on the left side of the PCB here, like right here. Okay? And that's where the power comes in. This little bottom cable plugs in right there, and then it does all the stuff. Now, my question for anybody that knows anything about electronics, okay? Looking at this, could this be built? Okay? That's my question. Can we build this? And it sells for $27, right? My question for you is, could this thing be built with these components for $10? That's my question. And I think the answer is no. I got a feeling I got a feeling I'm backing myself into a corner, because like this 24 pin connector, I know that's like $1. This Molex connector, maybe 50 cents. I assume these are capacitors. Okay? I assume these circular things are capacitors. And maybe those are cheap, hopefully. These things, the 4R7, I'm not sure what those are. but I can see resistors on here. I see these. I can't remember the names of these things, but I remember. I just don't remember what the names are. But these components are these components. All these components on here are they $10? Because if these components are $20 and he's selling it for 26, then I know my answer, right? Um, if for me to buy this stuff is $20 and he's selling it for 27, it's a no-brainer, right? If the stuff on here is $5 and he's selling it for 27, then I actually want to do this myself, right? Or I might want to do this myself anyway, just for fun, right? So if there's somebody out there that has the electrical expertise, potentially I could buy one of these, ship it to you, and you could decompose it, you could look at it, and work with me so that I know how to build this myself, right? That would be worthwhile for me, right? So if it, oh, that explains why I turned my volume down by accident. If I just turned my volume up, if this thing can be built for cheap, let's say if this thing can be built for $15, I want, and somebody wants to take the time and what's the word I want to use? Reverse engineer this thing, okay? Because it has all the numbers of this stuff on here, right? And with the electronic stuff like this, from what I understand, you can kind of look at these PCBs, and it's pretty easy to reverse engineer this stuff, right? Or using multimeters, touching stuff, you can reverse engineer and figure out everything, right? So if this is a $15 item and somebody wants to help me with it, I want to reverse engineer it, build my own. If this is a $20 item, we don't need to talk about it, because if that costs $20, if this is 15 or less, I want to do it. If it's 20 or more, I don't want to do it, because I might as well buy this, right? Now I know for a fact my motherboard, I measured the other day, my motherboard was using 64 watts of power, right? So this can run multiple rigs, and what I'm thinking about doing is, if I buy one of these, I'm pretty confident. Come on, I never know how to use that. See in the picture, the big connector here, it plugs into the motherboard right here, into the PCB. I'm pretty sure I can branch this into 2 cables. So instead of, again, the power, there's one power to get the 12 volt in, right? Then this is a 4-pin connector, which, that's a 4-pin to 4-pin. I'm not sure how that works. Is there a 4-pin? Let me count. Hold up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so there's only 10 connectors on this white thing. So 11 and 12, that is the 24-pin connector. It's a 20 plus 4. That goes in there. That's this thing right here. Maybe on this end he only has 20 pins. Can I look at the cable closer? What I'm thinking out loud is, on this end of the cable he might only have 20 pins, because there are 20 pin connectors, and then over here you might have a 24 pin, right? So, but what I'm thinking out loud is, I could take this cable, I could buy 2 of these, right? Or how would I do that? I would buy 2 of these. I would snip the cables. I would do 2 sets of cables. Basically, I would have one plug go in here, branch off to 2 cables, right? And build 2 cable sets so I could run 2 rigs off of this one thing. And so I could run 2 rigs for $30, and it would be small and compact, and with my HP server power supplies, and then I could sell 2 Corsair units at 750 watts, which I don't need, right? And 2 running off of this for sure, I'm pretty confident would work perfectly fine. First, I would want to run 1, check it. But everybody that talks about, oh, it's perfect for simple units with integrated graphics, and you're not going to run big graphics cards off of this. This is for people are buying this unit literally, and they're running their whole computer systems, including their IDE graphics, off of this system. So anybody that knows how to build this thing, drop a note in the comments. I can have one of these shipped to you. I'll pay for it, right? And if you're willing to reverse engineer it, tell me how to build it, show me how to build it, walk me through, hold my hand. If this does what I think it does, right? And I think what I could do with this, again, 300 watts, that's more power than I possibly need. So, okay. With that, let's go we looked at what to mine. Last but not least, let's wrap up with our crypto. Let's go look at, Craigslist. I look every day. Ooh. Craigslist, what I do is I say, show me the stuff that's posted today. I go look at it every day. People are out of their minds. So if I look at it every day, I don't have to look, at previous days. So somebody's listing a 980 Ti, which is older than the hills, right, for $225. A 2070 for $450. Got some action today. A bunch of junk, though. I say a bunch of junk, but so this, why would you have 5 6350s? What the? 5 Radeon HD 6350 DMS 59, $5. I have 5 of these that I pulled from working machine. Each card has the ability to run 2 DVI displays. Whatever that means. That's funny. I watched videos on recycling the gold connectors and stuff too. It's not worth it. So the 980 Ti, way overpriced. There's a website you can go to check resale prices on this stuff. This can be here forever. It won't sell. The 2070, I wouldn't. I would buy a 2070 Super or a 2080. But I think the standard 2070 is, I looked it up, the hash rates aren't that, it's not as good as like a 1070, for example. The Super is significantly better. Okay, so that's Craigslist. What? Okay, look that up. Check my Ethereum real quick. Again, I say that I was supposed to have 190 here. That's not true. Not with the new electricity numbers. Let me show you what that is real quick. Which it's going to make you cry. Makes me cry. So you look here, is my RX 580 is using 151 watts. Okay. And I probably could get that to run better. I hate the AMD overclocking, undervolting tool. I don't know how to explain it. The built-in AMD graphic thing, it's just terrible. So then I said 80% efficiency. So it's really using 188.75 watts. And then come up with kilowatt hours and price electricity. Oh, it's 44 cents a day, right? 45 cents a day. 30 days, it's $13 a month. What's the current Ethereum price? Let's go look that up, because that's a little bit old. That's out of date. Give me a quick second. Ethereum. Where's my whatever? Come on. 180. Well, no, it's not out of date. 181.19. So I have to mine just to pay the bills, okay? I have to mine 0.002475 Ethereum needed per day. 0.002. Now let me just see what that equates to times 7. Yeah, I don't earn that much. In a week I do about 0.000. No, wrong number. In a week, I do about 0.01350. That's kind of what I do. 0.135, not 0.173. So I'm not earning enough to pay the bill. So 0.2, this without electricity, if you turn this to 100% efficient, which I used to think about, that's what most people do. They don't really consider, right? So this is how they look at it. You see they're 198, and when the price was like 185, it was like 195, right? So if I go back to the web, you will see. Well, let me do two things. Let me undo that. Okay. So 2475 is what I need per day. And if I go back to the web, 2475, and I'm currently earning 185 instead of 2 whatever. So I'm not even paying the bills here. Which makes you wonder, right? Now the question is, can I hodl the coin, or again? But this is just one card. I mean, it's not like I'm really wasting a lot of money. What did I say? Yeah, $13 a month, and some of that's waste, right? So it's not very much. Okay, back to the web. We'll look at it. Let's look at Bitcoin dropped. It was 8,500. Remember, now it's back under. So that article's appropriate again. Now, the other thing I've kind of noticed here, and I think it's true, is gainers and losers. What was I changing? I was changing something on here. The size of this is a function of block size, market cap, or volume. That's what it was. Yes. Which kind of surprised me, okay? So market cap tells you where is the money invested, right? And I never really Coin360, I never really played with this much, but then I started looking at it. So SHA-256 algorithm coins are all in this block, right? And what's kind of cool, if you click here, you'll see it gives you Bitcoin, but then it gives you the SHA-256 coins over here as well, right? So it's like, oh, that's kind of cool, right? Likewise, if you come over to Equihash coins, I really like the Equihash algorithm. It's really good for GPUs, right? So if you click, you see what I did there? I clicked on the header. It gives me all of the coins in a better view, right? So where is Beam? Here's Beam right here. And you can see relative to all of the Equihash coins, or Equihash derivatives, we'll call them, because Beam isn't an Equihash coin anymore, it's a derivative. But you can kind of see the relative market cap, right? But if you come in here, and talk about volume, look at that. Look at that. Now, what does that tell you is, and the reason I found this interesting is, volume is pretty important, right? As far as whether a coin has a future or not. What you'll see is a coin like this, whatever that coin is, it doesn't have a future. Okay? That coin, let's take the red one that right there. Where did it go? What happened? Really? Look when you go globally. Oh my God. Block size by volume, okay? On the big picture, Tether, holy dear God. Well, yeah, remember we looked, it was like 6.5 or $5.6 billion, right? It's almost as big as Bitcoin. But that kind of makes sense. People are jumping between Tether and Bitcoin. They're basically ping-ponging back and forth, which doesn't surprise me, right? Now, Ethereum size is pretty big in my opinion. But if we come back, what I wanted to look at was my Equihash. I wanted to see this little crappy one down here. What do I have to do? Maybe you can't do it that way. Maybe I'm trying to do something that's not doable, right? So what I was playing with is if you look at it at market cap, that just tells you how much value in the total coins there are, right? Which to me doesn't really tell you a lot, right? It kind of does because a coin that doesn't have any market cap is, you know, if you again we look at this, look at Beam, doesn't have that much market cap, right? Not that much market cap, not at all. I mean, it's got, well, it's 1, 2, 3, 4, 5. It's like the fifth biggest for market cap, right? But if we come here to volume, it's definitely second in volume. So I just thought, now it's not letting me look at these little midget. I bet there's no coin down there. Watch this. That's what it was. I was clicking on an empty block. There's no words here. There's blocks here. That's weird. Whatever. These people are stupid. So if you click on it, now it gives me that coin, Snow Gem. So the Snow Gem coin is kind of, what I'm trying to say is, I don't want to mine Snow Gem because Snow Gem doesn't have market cap. Let's look at market cap real quick. I'm just learning this by myself, by the way, too. I haven't really used Coin360. Red Panda, by the way, he's a YouTuber that I recommend you watch. Red Panda Mining. Go subscribe to him. No. Yeah, Red Panda Minecraft. Red Panda Mining. He's almost got 10K subscribers. Stop already. He's the one that I watch use Coin360 a lot, okay? So he's got a 1660 MSI Gaming 1660 Ti doing 31.5 mega hashes, but he's still losing money. I almost bet money on it. He's been posting a bunch of videos about shutting down. And he's just doing onesie off cards right now. Anyway, he uses this Coin360 a lot. I was like, well, I wonder what it's about, right? So the point I guess I'm making is Snow Gem is where, you know, it's going to be one of these little stupid things down here, right? That's 0.0004. These other coins are, but as I learn this thing, what I've been finding interesting is trying to, it helps you to actually, like you could look at this, you could say market cap, beam, boom. You could say volume. A coin that has a lot of volume is a coin that has interest, right? So it's a coin that's good to mine, in my opinion. So it's just another tip kind of that I was looking through, and you could favorite these things. Not sure what that does. And I got a lot more to play through in here. Okay, that's weeding out the chaff. So that basically lets you cut the small guys out. Hide. What was that? I like double clicked. Come on. It's a different current. What? It's treating it as when I click on the menus like I'm clicking on. So don't click on it. Okay, so you can hide an individual coin out of all the coins too. Okay, so there appears to be a lot of stuff you could do here. Okay, so this is like the cryptocurrency.com or whatever it is. It's just a listing, right? Are these the Equihash coins? No. It's got to be, though. Anyway, I'm going to gainers and losers. 50 losers, 50 gainers. Yeah, see, it's stuck inside of my Equihash block that I've selected here, right? And when I say stuck in, that's all right. I've told it to come here, right? all. If you click there, you go back up. Or I could have clicked here, right? Hide filters. Okay, so there's a filter that's putting on somewhere. If I click back here, where's my Equihash? So somewhere it's putting on an Equihash filter. And if I say, is that my filter right there, quote unquote, right? If I say reset, it's going to bring me back to the top. Yep. Yep. The point being is the default, when I came here, it's like, okay, well, what does this tell me? The block size and stuff. And then I was like, market cap to me, I'm not sure I'm that big of a fan of market cap, right? That just tells you the longer a coin's been around, if it kind of hangs in there. Now, if a coin's been around a long time, but it's a shit coin, meaning the price goes to zero, then its market cap's going to be low, right? But if it hangs around, it does, let's say, mediocre, it's going to have a big block, right? Versus like Tether hasn't been around that long, but it's got a big volume block. But look at how small its market cap is comparatively, right? Look how small its market cap is. Now, you can't mine Tether, so this, it's not really applicable to look at this way. But if I was trying to use this to look at, hey, what do I want to mine? You look at volume. Oh, there's a lot of volume in Tether, right? Well, that's because people are bouncing because the market's crazy. So with that, guys, and if anybody can provide any additional stuff on this too, that's kind of cool, right? Like, there's a lot here. Walmart Canada launched blockchain solution. These people are. Now I don't mind this. They announced its blockchain-based freight and payment network will be live and blah blah, but they're not launching their own coin, right? I'm using the blockchain to track fish. So it says down here, Walmart has been actively researching blockchain. The company was involved in testing IBM's blockchain, right, for food supply management. So I think that's great. And I'm going to use blockchain to track fish and food security, right? Verge, I can't even understand. I still have Verge, but it's been hacked so many times, and millions of dollars have been taken out of Verge, but yet the price, I should probably sell my Verge as it goes up here. How much did it go up? Interesting. Okay. Thank you so much for watching, guys. I don't expect anybody to watch through to this far, but if you did, thank you. I appreciate it. You're probably asleep by now. If you can help me with the things I asked for help on, that's great. If you can help me with the electrical stuff I still need help on, If you want to help with CryptoPonics, by all means, do not hesitate, right? How do you search here? Coins, okay, if I could search right here. VRG, no, VRX, I'm just going to search Verge like that. XVG, that's right. It's been so long. What? Didn't the news just say there was a big surge on Verge? 7-day chart. Okay, well let me maybe I'm doing something wrong. XVG, yeah, that's Verge. I mean it was hacked. And I don't have a ton of Verge, but what is this? This just doesn't look like my coin. Because I thought Verge used to be like dollars. Okay, so here's what they're talking about. And I guess from a trader's perspective, you can make money this way, right? Maybe? Because it went from 003 to 004. And that was called what? It went to 005. And what was the news calling that? A huge price surge or something? I mean, it made the news for the price was 003 and it went to 005. I mean, a 37% increase. And from a trader's perspective, maybe that excites a trader, right? From my perspective, the coins I have are still worth shit. Except I could use them on Pornhub. Woohoo! Um, how funny is that? That is too funny. Now I see Chinese. The Chinese aren't going to do anything in blockchain because with their own crypto because no one can trust a communist government to do anything, right? So anyway, so that's interesting. There's my 30-gallon tank. I don't need that anymore. Got my Peltier devices. I asked for help. I showed you his channel. Oh, here's those cool latches I found. They're way cool. Peltier, we talked about that. The big thing to me, and you may laugh, I'm going to do some more calculations just to verify that I'm doing my calculations right. But I think, and I say I think if I homebrew and I vent my, based on my calculations, if I vent my CO2 into my greenhouse, because CO2 is so, people talk about CO2 like, oh, it's so prevalent, and you know what I mean. It's only 400. It's only 400 ppm, right? And I'm gonna have to go through and verify those calcs. That's what I'm saying. I'm gonna verify it again. But if I vent the CO2 for my brewing, it looks like it goes into the thousands of ppm. Now, that's over a 7-day process, right? So what I'm expecting is, and I'll have to buy an analyzer and do a study on this, but what I'm expecting is if I homebrew and vent my CO2 into the greenhouse is going to consume the CO2 at a phenomenal rate, right? Because the plants love Brondo, right? And so as I ferment, the CO2 comes off, the Brondo comes off, the plants say yummy, the plants eat it. And you saw the article. It said that if you can get the CO2 levels up to 1500, was it? Yeah, if you could get the CO2 level up to 1500, you can expect a 30% increase in your crop production, your crop yields. And then we watched that video, and the video was 1280 ppm or whatever it was versus 400 and some or whatever. And what did they say? 43 or 44% increase in productivity. So I'm kind of excited about this. And CO2, like I'm saying, is you have to think about what's coming off the fermenter. It's pure CO2. It's nothing but pure CO2. And the one guy said 133 gallons of CO2 for a 5-gallon batch. The other guy said 113. We took the guy with the low number as the basis, right? And it was what, 15? If I brew a stout, it's like 15 cubic feet for a 5-gallon batch. That's huge. That's 15 cubic feet. Now the greenhouse had what, 2,000? What was it? 2,060, 3,600 cubic feet of air is in the greenhouse, right? But if you could put 15, because remember 1.62 cubic feet is 450 ppm. So if I could put 15 cubic feet in there, what if I could put 45 cubic feet in there? Now, the other thing I think that I've read too is you got to be careful. So, where am I? There's such a thing as giving too much CO2, I think. So I have to test this, right? But if I'm brewing, I'm releasing CO2. Now, maybe I compress this. No, that would get too expensive. I'm trying to think how I would control my CO2 emissions. Well, one way I know how to control it is by cooling. The cooler your fermentation is, the slower it goes, right? So that might be another way to control if I get too much CO2. You can kill plants, from what I understand, you can kill plants with CO2. If you give them too much CO2, you can kill them. So the Beer Borghini and the Beer Borghini Junior, I went through the genesis of all of this. It's pretty wild, isn't it? And hopefully it's a good insight into how I think. And I think I'm going to do these because 1/2 inch bulkheads are cheap. And what I have to do each batch, I would have to disconnect the bulkheads, disconnect the piping, take it all apart, clean it. You know what I mean? Because to get this clean and sterile, you got to take it all apart and rinse it and spray it, and you know what I mean? And the actual item, it has a big screw lid on the top here, which is good for rinsing it out. And it's made of food grade plastic, so that'll be perfect, right? But hopefully you enjoyed the beer Borghini and the whole process and the videos and the pictures and the fans and the block. I got a lot of work to do. I don't know how I'm ever going to do this, but I will get it done. Maybe I'll find some volunteers here in the Houston area that want to come help me. So if you're watching this, maybe I should post an ad on, I could offer free beer. While you work, you can drink free beer. That's what I could do. And then I could homebrew for the people that come help so that it counts for their beer too. That sounds like a good idea also. Okay, thank you so much for joining me. As always, sub, like, share, do all the rest of the stuff. I enjoyed having you. I always enjoy having everybody, and I know I ramble and I go on. And hopefully I build up a viewership over here at CryptoPonics. Right now I saw I have 1 subscriber, which I'm so excited about. My first subscriber. Thank you. I didn't subscribe to myself, so that's the good news. It's somebody from the outside. Anyway, we will see you in the next episode.